This lecture is entitled The Scale of the Universe and corresponds to the second subsection of section 1.1. In his book, The Hitchhiker's Guide to the Galaxy, Douglas Adams wrote, "Space is big, really big. You just won't believe how vastly, hugely, mind-bogglingly big it is. I mean, you might think it's a long walk down the road to the chemist, but that's just peanuts to space." If you like science fiction, then recommended reading is this book, Hitchhiker's Guide to the Galaxy, and that quote is a nice segue to the hands-on activity to get a sense of the size of the universe. You can print out the PDF files in the folder or just follow along with the images on screen. The first challenge is to order these relatively small items by size. This is a little like that walk you might take down the road to the chemist. In England, a chemist is a pharmacist, and their drugs operate on molecular scales. Pause the video and arrange these pictures from largest to smallest. As a hint, the baseball bat is the largest object, being about 1 meter in length. Pause it now. Here is the arrangement from largest to smallest. What are the orders of magnitude differences between these objects? You start with the baseball bat of 1 meter. The next item, the baseball, has a diameter of about 10 centimeters, or 1/10 of the bat length. The marble has a diameter of 1 centimeter, which is about 1/10 of the baseball. The grain of salt has a dimension of about 1 millimeter, which is about 1/10 of that of the marble. Each object is about 1/10 in length of the preceding object. There are thus 9 orders of magnitude. That trip to the chemist in orders of magnitude is about 9 steps. When we consider space now, arrange these objects from smallest to biggest. As a hint, the baseball bat is the smallest object, being about 1 meter in length. Pause the video and arrange the objects, then continue to see the solution. Pause it now. Again, in successive powers of 10, the orders start with the baseball bat, then the giant squid, then the pyramid, taking now 21 steps to get to the size of the Milky Way galaxy. Each step being an order of magnitude factor of 10. Space is, as Douglas Adams says, mind-bogglingly big. Those 21 steps only get from the baseball bat to the Milky Way diameter, and they make the simple walk down to the chemist down to the order of glucose or an atom very small in comparison. The distance to the farthest known objects in the universe are 10 to the 26 times greater than the length of the baseball bat. The universe is huge. One of the biggest challenges in astronomy is measuring the distance to stars and galaxies. We use time travel of light to measure the vast distances of the universe. Figure 1.2 in your book illustrates how light travel can be used to measure distance. The speed of light is 300,000 kilometers per second, and it is a cosmic speed limit. No information can travel faster than the speed of light. Light travels the distance of Earth's circumference in 1/7 of a second. The distance to the nearest star, Proxima Centauri, is 4.2 light years. By analogy, the time it takes for light to travel from the star to the Earth is about the amount of time you spend in high school. And the time taken for light to travel the diameter of the Milky Way galaxy is about the age of our species. Take a look at figure 1.2 to get a sense of these time travel and distance analogies. For the observable universe, the farthest back we can see in time is about 13.8 billion years. It is time, not space, which limits our view. Beyond a certain distance, light hasn't had time to reach us yet. So how big is the universe? No one knows if the universe is infinitely large, or even if ours is the only universe that exists. The photo of the cosmic microwave background radiation presents a paradox. Is it the oldest photo or the youngest? It represents light from the early universe just after creation, but it took about 14 billion years for that light to reach us. It shows us what the universe looked like before stars and galaxies formed. The universe is expanding. When we account for that expansion, the actual known size of the universe is much, much bigger. The universe is about 13.8 billion years old, and the observable universe is about 10 to the 26 meters in dimension. I suggest that you watch the original movie Powers of 10, and if you like, the Simpsons couch gag parody of it, to get a better sense of what these orders of magnitude mean.